We're going to do one more. I think we're going to do one more. Yes. We're going to do one more. Use the difference quotient to find the derivative, and then find the gradient of the tangent line at x equals 1. What does that mean? What does that mean? Slope. Slope, how do you find the slope?
You plug in x at the very end.
You plug it in at the end. At the end of doing what?
Finding the derivative.
Finding the derivative. Very good. Okay, so you're going to find the derivative, and then to find the slope of the tangent line, you're going to plug in a 1 after you get the derivative, okay? So go ahead and do that. This is the last one, and then go forward. So when you plug in into the formula, the difference quotient, you have this. Your 2's cancel, x squared, leaving you with okay. So then once you simplify it some, you'll have 2x plus h minus 1. Okay? And so when you plug in 0, you'll find out that your derivative, using proper notation, is 2x minus 1. Did you guys get that?
Yep.
So then the slope at 1, that's how you would write it, okay, is equal to what?
1.
Is equal to 1. Okay? So we're good with using the difference quotient. Yes? Awesome. This is the formal definition of first principles of calculus to find the derivative of a function. Okay? So, the next page, you don't have to write it down, I just want you to take a look at this, okay? Do you notice anything about the derivatives of these problems? These are all the ones that we've done. Do you notice anything?
It loses an x.
Mm-hmm. So, if I bring this down, that x squared turned into a 2x, right? Same thing here, that x squared turned into a 2x. So if I follow that same pattern, then this, it turned into 3, but it was a 3x squared, not a 3x.
You only bring down
How can you explain that? I mean, did that apply to the other 3 above it?
Oh yeah, it can because when you pull it down from 2 to 1. Yeah, so it's
So
a
now
x to 1.
So you can say that the exponent loses 1 when you bring it down in the front, right? Okay, so then that means that if I were to bring this down to the front, you have to do what?
Multiply by 3.
So I have to multiply that number by 3, that's how we got 6, and then this would be 2 minus 1, which is 1, right?
Yeah, and then you did the same thing on 2x.
Same down 2, because what's the exponent right here?
1.
A 1, so when you bring that down, that's 2 times 1, x, and then 1 minus 1. What's 1 minus 1? 0, anything to 0 power is? How do you explain this last one though?
Oh, because it's a negative. Yeah.
The exponent's a negative 1.
Yeah.
So the same rule can apply. If I bring this down to the front, that gives me a negative 1, x, and what should we do to the exponent? So you get negative 1x to the negative 2, and to make that exponent positive, what do you do?
Take it to the bottom.
Take it to the bottom.
Wow. So we can really do that and solve them now?
Yes.
Yeah, I agree with Sage.
Something's about to get really hard though. Yeah.
Take a picture.
We're gonna do plenty of examples. This right here is known as the power rule. You can use it for these types of functions to find the derivative. Okay? So you have the formal definition, and then you have the power rule. Either way, you'll still end up with the same answer. So what we're about to move into is some of the rules that deal with derivatives. Okay? So the power rule, which is what we just talked about. Whenever you have a variable raised to n represents whatever your exponent is, okay? Then to find the derivative, all you do is exactly what you guys said. You bring down the exponent and then you subtract 1 from the exponent, okay? That is known as your power rule. So this is how you can go about finding the derivative. You take the exponent, you bring it down to the front, and then you subtract 1 from the exponent. So if I look at A, which is 5x, or sorry, not 5x, x to the 5th, then using the power rule, I can easily just bring down the 5 to have 5x, and then subtract 1 from the exponent to get that. And there's the derivative. It would be the same thing that you would get if you were to use the formal definition, plugging in your x plus h's, expanding it, taking out a common h and plugging in 0. Okay? So if we take a look at B, what would the derivative be?
8x to the 7th.
Very good. Now before we can take the derivative for C, what we need to do? Bring it to the top. So when we bring it to the top, that turns into a what?
1x to the negative 4. And then you put negative 4 out. It's
Right.
negative 4x,
So it'd be a negative 4x,
and then negative 4 minus 1.
negative 4 minus 1, which is
Negative 5.
negative 5. And so then we want to rewrite this,
Negative 4 over x.
negative 4x to the 5th. Because the negative only applies to the variable, not the 4. Okay, question?
Just one example, where'd you get the negative 5 from the exponent?
Because remember, after you bring down the exponent, you always subtract 1.
Oh, okay.
So that's that n minus 1 part.
Okay.
All right? Questions? Questions? What about D?
Ooh.
Hold on, wait, don't say it. Think about it. Before we can take the derivative, we might have to do something to it. Okay, to use our power rule, we need an exponent, right?
You can rewrite that.
You can rewrite this so that it has an exponent.
Yeah.
Power 1 over 3.
X to the power